Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aiza Alicia binti Hasim. So today I want to present my final year project proposal, and my title is Tribological Studies of Nickel Graphene Oxide Nanocomposite Coating, the effect of coating deposition pH. This is my content, so I just proceed to the background of study. Tribology. So what is tribology? Tribology is a field of science examining the frictions, wear and lubrications. Tribology also is a field of science and technology that deals with contact surface in relative motion. So in early century, tribologists play a very important role in technological evolutions by reducing friction, that make possible for human to move further and faster using wheels. So tribological studies can lead to increase the efficiency, less breakdown, improve performance and cost saving. For the background of study, I'm gonna start with coating. Coating is actually a film of metal or non-metal or ceramic produced on a surface of metal to enhance the tribological and mechanical properties. The parameter and the preparation of substrate obviously going to affect the efficiency and the durability of the coating. For the graphene is not something new. It's already discovered by a lot of researchers before. Graphene is actually one atom peak is a 2D hexagonal lattice layer of carbon atoms. It has very excellent mechanical and tribological properties and has very high mechanical strength and elastic modulus. Graphene also anti-corrosion properties and great material for coating. For the graphene composite, graphene usually combined with other material that we call it nanocomposite just to improve the material properties such as the tribological behavior and the mechanical properties. The other material that usually combine with graphene is copper, nickel and aluminum. For the problem statement for my proposal, the coating of composite nickel and graphene or graphene derivative has been recently studied by few researchers. There are only few number of research on the tribological behavior of the nickel graphene and its derivative. The tribological behavior of coating will be investigated using pin on this tribometer. So the objective of the study is to investigate the tribological properties of nickel graphene oxide nanocomposite coating deposited at different pH value using pin on this tribometer and to characterize the morphology and surface roughness after the tribo test. For the scope and limitations, I focus on the tribological properties of the nickel graphene oxide nanocomposite coating. Tribological properties of this study will be investigated based on the lab work testing. For the limitation, because of the corona season right now, and the latest one is Omicron, so FOP or full scope of procedure is very important just to prevent the spread of corona during using the machines, because some of the students will be use the same machine to test the sample. Electrodeposition. Electrodeposition is actually a method used for metallic coating process that perform in aqueous solutions. So basically, the substrate will be connected to the negative terminal while an electrode is connected to the positive terminal just to allow the current passing through. Electrodeposition is very good compared with other method because it's very simple, it has a speedy result and binder-free method. It's also very universal because it can be used with various type of substrate. It don't have any special condition. It can be performed in room temperature and atmospheric pressure. The main advantage of this process is that the nanoparticle will be attached directly to the substrate, and also the process can be controlled easily by adjusting the operating condition and also the bus solution such as the temperature and the pH value. Nickel graphene composite coating. For graphene, graphene has excellent strength of up to 130 gigapascal, which is 100 times higher than tin. In composite coating, graphene is shown to provide surface with improved tribological properties such as the wear, hardness, and corrosion resistance. For nickel, nickel has excellent strength and long-term failure resistance, mild stiffness, and lower thermal expansion coefficient. When the graphene oxide is added to the nickel, it's going to produce a lubricating effect by generate a transfer film on the coat surface, lowering the coefficient of friction. The dispersion of graphene in the nickel matrix may be uniform, which can improve the mechanical characteristic of nickel composite. When the quantity of graphene in the composite coating increase, the weaker micro hardness of the coating also gonna increase. The adaptation of graphene will enhance the hardness of nickel coating. The graphene intrinsic high mechanical strength may have contributed to the composite coating's increased hardness. As you can see here, for the nickel graphene, the micro hardness is higher than the single nickel. And for here, this is the hardness test. As you can see, the nickel graphene has lower depth compared to the single nickel. This is the tribology properties of nickel graphene composite coating. Nickel graphene composite coating has less wear rate compared to other coating that don't have graphene in it, and the coefficient of friction and wear rate decrease as sliding speed gonna increase. The average coefficient of friction and wear rate of nickel coating are higher compared to the nickel graphene coating. The addition of graphene to nickel matrix was found to reduce the wear while provide low friction. Wear on nickel graphene coating surface will lead to exfoliation of graphene from the coating, which allow the nano-sized particle to enter the aspirate contact and reduce the friction coefficient. The increase of graphene content in nickel graphene composite coating can result in less coefficient of friction and wear rate. Zushali et al. Reported that the friction coefficient of the nickel graphene composite coating is reduced and average value is maintained at 0.16. As you can see here, the black one is the nickel graphene, which is maintained at 0.16, and the red one is nickel, which is maintained at 0.44. The nickel graphene is around 63.6% lower than the nickel. This shows that the friction coefficient of the nickel graphene is less compared to the nickel. This is the flowchart for my future experimental work. So I'm gonna start by prepare the substrate, which is the mild steel, and prepare the bus solution with different pH value. Start from 2, 3, 4, and 5, and proceed to the electrodeposition process. For the test, I'm going to start for friction and wear test using pin-on distributor and characterize the material using X-ray diffraction machines, scanning electron microscope, and the Alicorn infinite focus. And the result will be analyzed. This is the test parameter. The coating will be deposited at pH between 2 until 5, as I mentioned before, 2, 3, 4, and 5. The load, sliding speed, and the duration will be remain the same, which is 10 to 50 and 20. For the expected result, the pH will alter the coating deposition of nickel graphene oxide, thus will also affect the tribological performance. The outcome of this work will contribute to the understanding of tribological behavior of nickel graphene oxide composite coating when fabricated at different pH value. This is my project planning for FYP 1 and FYP 2 that's gonna end in 2022, inshallah. This is some of my reference, and that's all from me. Thank you.